Okay, the third of our miscellaneous topics is what we call the angle between two lines. So, again, this is sort of an extension of some of the work in trigonometry and coordinate geometry combined. So what we want to do is find an angle that's going to be between two lines. Now, we're going to find the acute angle. If we find the acute angle, well, the obtuse angle would be easy to find as well because it's just along a straight line. So to prove this formula, and this is the formula we're going to use, but it comes from the idea that if we've got two lines intersecting, okay, obviously they're going to have be at a certain angle, alpha and beta, if we let them be that. So if we want to find our angle between our two lines there, what we do is we've got a situation where we've got a triangle here. Now we know the exterior angle of a triangle is equal to the sum of the opposite interior angles. So alpha is equal to alpha, theta plus beta. So that means theta would equal alpha minus beta. Now tan of an angle would be equal to tan of another angle if those two angles are equal. So given that situation, we've got tan of alpha, theta is equal to tan of alpha minus beta. Using our extension 1 rules, we expand that out. Tan of alpha minus tan of beta over 1 plus tan alpha tan beta. Now we know that from this, tan alpha is equal to m1 and tan beta would be equal to m2 because that's the angles of the line there. So that would give us the m1 minus m2 over 1 plus m1 m2. Now we take the absolute value because the absolute value would give us a positive number every time, and tan is positive in the first quadrant, so it would give us the acute angle there. So if we left it as a negative, it would give us an obtuse angle. And if we want to find the obtuse angle, we'll be able to do that as well. But it's easier just to find the acute angle every time and then find the obtuse angle between those two. So let's have a look at two situations. If the lines are parallel, well, m1 would equal m2, so the numerator would be equal to 0. So we get tan theta is equal to 0. So you're going to have that situation. So if you see that you work out tan theta is equal to 0, then the lines must be parallel. If they're perpendicular, well, the gradients multiply to give you minus 1. So that would give you 1 plus minus 1 in the denominator, which means that tan theta will come out as undefined. So if you have that situation, the lines are perpendicular. So they're going to be it's going to be at 90 degrees. So applying the formula here, what we've got to make sure we can do is get our and when we've got two lines there, we need to get the gradients from each of those. So we need to be able to manipulate those and back into our gradient intercept forms, or whichever way else you do it, and then apply the formula. Tan of theta is equal to the absolute value of a half minus the third over 1 plus a half minus a half times the third, and do that calculation. We get the absolute value of 1, which means we take the inverse tan of 1 there, which gives us 45 nicely. You'll find a lot of these questions work out that way. It's like, because it's nice whole numbers, nice numbers there with 45. If you want to leave it as pi and 4, go for your life. That would mean the obtuse angle between the two would be 135, because 180 minus 45 is 135. Manipulating the formula to do a different type of question, 2x minus y equals minus 7 is equal to 0, and y is equal to mx plus 3. We've got to find m. So, and we're told the angle between it's 45. So if that's the case, so we get our gradient there, we apply our formula, and tan of 45 is equal to absolute value of 2 minus m over 1 plus 2m. So from that, what we can do is have a look and go, well, 1 is equal to the absolute value of that. So how do we solve an absolute value question? Whatever's inside the absolute value sign's either got to be equal to 1, or it's got to be equal to minus 1. So if all that inside is equal to minus 1, the absolute value of minus 1 would be 1. So that's why we set up our two equations and then start to solve those. So we multiply by the 1 plus 2m, and we get n is equal to a third, solving that equation, and multiply by the 1 plus 2m here, we get the minus 1 minus 2m on the left side, and then solve that to get m is equal to minus 3. That's the application of the formula. Not a hard situation, but you've got to remember that formula, and it comes from our tangent rules, expansion of tan rules that we used before. in the extension 1 trig functions.